Hey, welcome back. Today we're going to be looking at definite integrals. So this is probably the next thing you learn in your calculus class after maybe the power rule or the first fundamental theorem of calculus. And what definite integrals are used for is to find the area under the curve on an interval of a function. So what this is equal to, this area, if this is f, would be the integral from a to b of f of x dx, or based on the first fundamental theorem of calculus, the antiderivative of f of b minus the antiderivative of f of a. So let's do a quick example problem. So here's an example problem, and before I start this, I just want to make one quick general note about definite integrals so that you can understand this. It's pretty important. If you ever take a definite integral and you get a positive result, that means you have area above the x-axis. And if you take the definite integral and you get a negative result, that may be kind of confusing, because if it's area under the curve, how can area be negative? Which you're right in thinking that, but all that it means is that you have a positive area, but it's just under the x-axis. That's why you're getting a negative value. So the first step in taking the definite integral is finding the antiderivative of this. So to do that, we can just use the power rule. So add 1 to the exponent, so we have x to the power of 4, and then divide by our new exponent, so 3 over 4, minus add 1 to the exponent, so we have x to the third, and then divide by our new exponent, so 1/3. And then if it's a constant, all we're doing is just multiplying by the variable, which is x, and we don't have to worry about the plus c in this case. So what we're going to do now is draw this line and write the bottom, or the lower and upper limits to show what we're plugging in. And now we go ahead and first plug in the upper limit. So 4 to the power of 4 is 256. So 256 times 3 is 768. So we're going to have 768 divided by 4. And never simplify this, at least not yet. So now we're going to plug in 4 to the power of 3. So 4 times 4 is 16. So it should be 64 minus 64 over 3. And then finally we'll plug 4 in there. So we'll have plus 16. And now just leave these fractions unsimplified. So what we want to do next, right below that on your paper, is plug in 2 to the same equation. So 2 to the power of 4 is 16, I believe. So 16 times 3 would be 48. So we have 48 over 4 minus 2 to the power of 3 is 8, so we have 8 over 3. And then finally plug in 2 here, so we have plus 8. And now, remember the first fundamental theorem of calculus says that the definite integral from a to b of a function is the same as the antiderivative of that function of the upper limit minus the antiderivative of that function of the lower limit. So what we're focusing on here is that minus. So what we're going to do now is flip all the signs of the bottom equation, because we're doing this top equation minus this. So minus plus, we'll make that minus. So now we just go top down and just evaluate that. So 768 minus 48 would be 720 over 4. So we have 720 over 4. Whoops. 720 over 4. And then negative 64 plus 8 would be 56. So we have minus 56 over 3. And then 16 minus 8 would just be 8. So now the last step in this process, and this isn't necessarily, unless you would like to simplify it, but sometimes you'll have to on a multiple choice question or something like that. So what you're going to do is multiply by the common denominator, like multiply to make a common denominator so that you can subtract, and then add everything, add the 8 at the end, and make everything into one term. So to do that, we're going to multiply 720 by 3. Here, I'll write it here. We're doing this times 3 over 3, and we're doing this term times 4 over 4. So we'll multiply the 8 by 12 over 12. So if we do that math, we have 720 times 3 equals 2,000. Here, I'll erase something. I'll erase the original integral so we have extra space. So we have 2,160 over 12 minus 56 times 4, which is 224 over 12. And then finally we have 8 times 12, which is equal to 96. So we have plus 96 over 12. And now finally the last step in this process is we just do this arithmetic. So 2,160 minus 224 plus 96 is equal to 2,032 over 12. And if you divide that, you get 169.33 repeating. So, or 0.333, I guess. So this is your final answer, 169 and a third, or 2,032 over 12. So that would be the area under the curve of that function on that interval.